fish, then you must know what type of water do you need to culture a fish. Water for culturing fish. This is very important factor that you must know if you want to culture a fish. The main water sources are municipal water, table water, rain water, runoff water, surface water, and groundwater. These are the sources from which you can get water. Municipal water. Municipal water is a tap water that's sent to various industries and homes through pipes that have been placed underground. This water is fully treated and processed before it is sent to these destinations, which means that the majority of impurities are removed before you drink the water. Use it when taking a shower. There are some advantages and disadvantages of municipal water in culturing a fish. Some advantages and disadvantages of municipal water. Advantages are these: it's easy to use for culturing a fish, and quality is good than other water sources because municipal water is already treated with different processes. And disadvantages: it is expensive to achieve large amount of water. It may contain toxic chlorine or chloramines. If this water is not treated before, then you can get these toxic material in this water. To clean toxins, cost is very high. It may cost efficiency for humans. If you use municipal water for culturing a fish, then this make a shortage for the humans use. Rainwater and runoff water. Second source for culturing a fish may be rainwater. You can collect this water from rain. It is water which comes from the rain and then collected for different purposes. And you can use this water for culturing a fish. It is called runoff because it enters into other sources after falling down on earth. After raining, this water enters into ocean, lakes, streams. You know well, after raining, where water gone, it can be used in those areas where rain is high and annual evaporation is low. There are some advantages and disadvantages of this water for culturing fish. Now, what are the advantages of the rainwater? Inexpensive, does not have chemicals like chlorine or chloramines because it is already purified in sky or in the clouds. Disadvantages may contain contaminants, industrial pollutants may cause acid rain. If rain is happening in such type of area that contain industries, then you can get these contaminants. Susceptibility to droughts or the floods. Its replacing is very difficult because if rain is not happening anywhere, then you can't get water because you are relying on rainwater only, used in some areas where conditions are feasible for rain. In this picture you can see a sketch where rainwater is come and where it gone, and how pollutants added in the rainwater. Because if there is a acidification in the soil, then when water fall on the soil, it contains such type of acids from the soil. Lakes turn acidic, and then when acidic water will go into the oceans or the streams, then it also turn the ocean water into acidic water. And you can see in this picture the smoke that released from the industries. It contains contaminants like sulfur dioxide or argon oxides that will add into the rainwater, and it will convert it into the ammonia or nitrates or different nitric oxides that may cause different type of diseases in humans if human use this rainwater. Or it also cause diseases in many animals if this water added into the rainwater, this rainwater added into the ocean. Another source for the culturing fish is the surface water. Surface water is any body of water found on Earth's surface, including both. You can get this water from the surface, and it may be from the salt water in the ocean, and it may be from fresh water in river streams and lakes. Lakes and reservoirs can be a good source of water. The water from them can be flowed into ponds or through raceways. Lakes and reservoirs can also be used as sites for cage culturing. Another source is the marine water. 70% of the Earth's surface is covered in water. You know well how much area is covered by the water. 97% of that water is salt water, that is the marine water. Marine ecosystems are the largest types of ecosystem on the planet. What are the advantages of the marine water? Good source of water for marine fishes, but not good source for the freshwater fishes. Good source of the seafood. And what are the disadvantages of marine water? Only cultured marine water fishes, for example, salmon. Salt content is more, so pH values are high, difficult to use in the intensive culture. You should know about the intensive and extensive culture. What is the intensive culture? Intensive culture is that area where you are culturing a fish, but in small area, which is not very much extensive as present in the natural environment. In these fishes, numbers of fishes are very low as compared to the extensive culture. Another source is the fresh water. Fresh water is water that contains only minimal quantities of dissolved salt, thus distinguishing it from seawater, brackish water. All fresh water ultimately comes from the precipitation of atmospheric water vapors reaching inland lakes, rivers, and groundwater bodies directly after melting of snow or ice. Also, you can say that fresh water comes from the rainwater. And what are the advantages? It's easy to use for intensive and extensive culture, easily available for culturing fish water. Fish is a disadvantage, only suitable for freshwater. Trout fish is not for the marine fishes, for example, salmon. Groundwater, another source that you can use for getting water for culturing the fish, is the water found underground in the cracks and spaces, the soil and rocks. It is stored and it moves slowly through geological formations of soil, sand, and rock called aquifers. And this is the main source that you can use for culturing a fish. In this picture, you can see from where groundwater is coming and where groundwater is present, and the gravel during the fractured rock fills the spaces between soil particles and fractured rock beneath the earth's surface. Then this groundwater comes up to the land surface, and the trees use this water for nourishing. Advantages of the groundwater is often preferred source for aquaculture, particularly if its abundant supply of good quality water can be obtained without having to drill a deep well. Natural filtration to remove organisms and suspended materials such as silt and clay from the recharge water. What are the disadvantages? There are not so many disadvantages of the groundwater, but there are some disadvantages. Bubbling of air well water can ensure iron to precipitate to form ferric hydroxide. It will stain pipes and other surfaces, and if present and high enough level, it can clog gills. Yes, when there are any metal in the water that can clog the gills of the fish, then fish will not grow very well. Well water can come to the surface depleted in oxygen and may contain a relatively high level of such things as hydrogen sulfide, iron, or carbon dioxide. Then aeration is needed to solve this problem. And aerators are used for such type of problems. Aerator maintains the normal DO, that is the dissolved oxygen of this water. Here you can see if there is any bubble in groundwater, then it can seen in the eyes of a fish. Indication of gas bubbles disease in fish downstream from spillways with bubbles in integument. You can see in picture A and in picture B exophthalmos. Picture B you can see in the eyes. AB along with the rays of the pectoral CD. In the picture C and D you can see the bubbles in the pectoral fin, and in the gill filaments in the F. Yes, bubbles can be in gill filaments, in eyes, or in the pectoral fin or rays. What are the main water characteristics and that must be present in water for culturing a fish? That are the biological character, physical character, and the chemical character. Biological character: microbes, bacteria, phytoplanktons, zooplankton, that are swimming biological cover living in wild larvae of the cryonomus plumosis, algae and aquatic weeds. Biological cycle: nutritive substances in solution in organic state. In the biological cycle, this is the first step in which the nutrients are present in organic form. Formation of higher plants, lower plants, and the phytoplanktons. From inorganic stage, it will be the second stage, that is the organic stage. Then phytoplanktons are consumed by smaller organisms that are the microfauna. Microfauna and other plants are eaten by the fish. This is the fourth stage, and fifth one is the reduction stage, in which the mineralization mechanism by the bacteria. Bacteria converts the minerals from one form into the another form, or it may be converted from the combined form into the free form. This is the picture where you can see aquatic vegetation, phytoplanktons, and after that bacteria will decompose these aquatic phytoplanktons. Then lower aquatic fauna will be formed, in which the microfauna, macrofauna in the animal organic stage. This is the animal inorganic stage, and before this stage is the inorganic stage, and next stage is the fish production. From these organic material, fish will get its nutrients, and then bacteria will decompose the fish, again converts these fishes into the inorganic nutrients or materials. Then again these inorganic nutrients will be used by different plants, and again cycle will be repeated. Microbes such as bacteria perform following function. Organic matter decomposition. What are the function of bacteria? Bacteria will do decomposition of organic matter, that is in nitrification, conversion of ammonia into the nitrates. Nitrosomonas, nitrobacter, these are the bacteria that converts the ammonia into the nitrates, because nitrates are the good nitrogen based nutrients for fish, but ammonia is not a good nutrient for the fish. Chemotrophic bacteria. This is the another type of microbes. Zooplankton, rotifers eaten by fry and small fishes and other aquatic animals. Brachionus, Triarethra, Polyarethra, and worms. Oligochaetes, Nitidi, tubifax crustaceans. Molluscus that contains gastropods. Insect generated as larvae and named, for example, Ephemeroptera and the chironomids. These are the zooplanktons that are eaten by the fish. Aquatic weeds are also important for culturing a fish, or it must present in water. Partially aquatic weeds. There are different types of weeds, but most common types are these partially aquatic weeds, that are shore weeds, Filipendula almeria, paludal weeds, semi-emergent weeds, completely aquatic weeds, floating plants, for example, Nymphia alba. Many aquatic plants are harmful when they become excessive. This especially applies to emergent weed and floating weed. Weeds are very important for culturing a fish in water, but if the weeds are present in higher numbers, then it will be harmful. What are the harmfulness that is due to the excessive weeds? First one is movement of fish will stop and water will not be warm for fishes. It provides refuge to competitors seeking nourishment. It provides refuge to enemies and that cause harm for fish. Aquatic weed growth provides cold water areas ideal for mosquito breeding. Recreational activities like swimming, fishing, boating will be affected. Weeds impede water flow in drainage ditches, irrigation canal, and culverts, and cause water to back up. It may cause problem in the drainage system. Oxygen depletion due to the consumption of more oxygen by the weeds at night. Controlling aquatic weeds. How you can control aquatic weeds? And you can make water feasible for culturing a fish. Aquatic weeds can be controlled by following methods. These are the most common methods that you can use for control a aquatic weed. First one is the biological method, in which herbivores, animal and fertilization materials are used. Mechanical method, weed cutting. You can cut the weeds in water, and that will reduce the number of weeds. And other method of weeding. Chemical method, in which you can use herbicides that will kill the herbs. Physical character of water. What are the physical character that must be present in a water that we are using for the fish? Color, its temperature, and its turbidity must be in some. It must have some characteristics. What color must be in fish water? A light green color of water is good for healthy fish pond. You cannot use the water that have black color. So you can use a water that have light green color. Dark green color is not good for fish, or dark black color is also not good. This is due to the many factors such as lack of proper filtration and beneficial bacteria to clean out water over time. Using too much fish food. Ammonia and nitrates caused by the fish waste due to the more algal blooms. You can see the algal blooms in this picture. That is not good for the fish. Temperature has a considerable influence on the vital activities of fish, such as breathing, growth, and the reproduction. Temperature must be feasible for fish, because if you want your fish growth very good, then you must understand the role of temperature that it plays for the growth in water. It affects the metabolism, feeding, growth, reproduction, distribution, depth, swimming speed, and the survival. And in these graphs you can see how temperature affects fish. Best ways of controlling the temperature of pond. How you can control the temperature of a pond? Best way to control temperature is increasing or decreasing of water. During the growing period, it is good to increase the temperature, but there is reason to reduce the temperature. For example, when it is 30 to 33 Celsius, it will cause reduction in growth of carp. Different fishes having different limits of temperature. In these limits, these fishes grow well. As you can see here, carp can grow well in below 30 degrees Celsius, and if it will increases, it will cause reduction in the growth of carp when it is 30 to 33 degrees Celsius. And if it will be below 30, then it will be good for the carp. Turbidity is the presence of suspended solids and the excessive concentration of the phytoplankton that can reduce the penetration of light in water. Yes, turbidity may be due to many reasons, but it will cause disturbance in light. If there is not a specific light that fish need, then it will cause it will affect the growth of fish. Suspended solids are the pieces of the particulate matter large than 0.45 micrometer that occur in the water column. If a particle is smaller than 0.45 micrometer, it is considered to be the colloidal or dissolved. It consists of the following most common silt, mud, and sand organic particles, plant and animals. Effects of turbidity. These are the negative effects that turbidity cause. It will make the phytoplankton bloom in the pond, and it will be difficult for light to penetrate in the water. Gills may become clogged due to this. Dissolved oxygen will be affected. Eggs being hatched in outdoor ponds can be buried and smothered, and feeding may be impaired due to the low visibility for side feeding species. Turbid water tends to warm more quickly than clear water, but it cools more slowly, so it will be difficult to maintain the temperature of such type of pond that have turbid water. Control of turbidity. Turbid water should be allowed to settle or be filtered before being put in culture chambers. Large volume of water is difficult to filter, so source of water should be selected carefully. Add gypsum. Yes, you can use some chemicals for reducing the turbidity. First one is the gypsum. Calcium sulfate water and alum was found to be effective when used at 15 to 25 milligram per liter. Chemical characteristics of a water. These are some chemical character that must be present in these ranges in water, and then your fish will be grow very well, and you can get a good growth of your fish. Dissolved oxygen pH value, ammonia load, nitrite, salinity, alkalinity, hardness, toxic and load. Dissolved oxygen is linked with the temperature and vegetation. If the decomposing organic matter is in large amount, then dissolved oxygen will be reduced. Danger of fluctuation in dissolved oxygen mostly occur during warm and thundery weather when ice covered the surface of water. All vegetation can be affect dissolved oxygen during day. It can be increased above saturation level during night. The same vegetation absorb the oxygen and can reduce the level for dissolved oxygen in the pond. Dissolved oxygen for salmonid is the 19 milligram per liter and temperature is 20 degrees Celsius. For cyprinids, it is dissolved oxygen is 6 to 7 milligram per liter. What are the negative effect if there is insufficient dissolved oxygen in water? When there is a low oxygen, fish come to the surface in an effort to breathe here. Other fish group together near the freshwater inlet where they behave normally. Fish killed by the asphyxia have raised gill covers and their gills are wide apart. Here you can see if the fish water have less amount of dissolved oxygen, then these symptoms will be clearly seen in the fish. pH level. Water can be neutral at 7 and it will be acidic. Lower the pH and then 7 and it will be basic. pH is higher than 7 due to the change in the pH, or we can say it alkaline. Best fresh water for fish cultivation is that which is neutral or slightly alkaline, 6.5 to 8.5. That you can see if the pH is between 6.5 to 8.5, then this water will be good for fish. Best salt water for fish cultivation is that which is alkaline above 7. This is maintained with the presence of molluscs because their shell contain calcium carbonate. If pH drops from 7, then buffering compound is added in salt water such as carbonates and bicarbonate, iron, limestone, oyster shell. Calcium carbonate will convert into the calcium as carbonates, and then carbonate will be converted into bicarbonates. Changes in pH. Marshy and peaty water mostly have acidic pH. Due to the low calcium pH, will drop suddenly and cause fish death. Determination of pH. How you can determine the pH of fish water? Colorimetric method, electrometric method, and a litmus paper test strips. Ammonia load. There's a name of scientist Hoshaka 1969 indicated that most of the nitrogenous waste fish produce is in the form of ammonia, which is excreted through the gills. Ammonia is present in two forms: Ionized form. This is the toxic even in low level and effect on growth, and the gills become deep form. Ammonia level for cold water species is 1 mg per liter, and for warm water fish is 2.5 mg per liter. Above these values, fish will be affected. Component effect ammonia. What are the components and that affect the ammonia level? Dissolved oxygen, carbon dioxide, hardness, and bicarbonates, carbonates. These levels, the levels of these chemicals must be in limited amount in water. Determination of ammonia probe, and colorimetric test of ammonia. Nitrite. Mostly nitrite are not present because they are converted into nitrates by the bacteria. If there is amount of nitrite present in water, then it will be harmful. Or you can measure the nitrites from the colorimeter. This is the instrument that you can use for measure the nitrite, and a spectrophotometer. These are the components that affect the nitrite limits in the water: salinity, ammonia, temperature, pH, nitrates, sulfates, phosphate, and the calcium. Effect due to the more nitrite. Due to the higher amount of nitrite, fish will be affected. In what ways? It will combine with the hemoglobin in the blood of finfish to produce methemoglobin. Methemoglobin will not combine with oxygen, so the fish will be asphyxiated when it loses its hemoglobin. A chocolate brown color of the blood is a sign that the hemoglobin has been converted to the methemoglobin. How you can treat this condition? You can use table salt for each milligram of nitrite that is present in an effective treatment for the condition known as the methemoglobinemia. Increase the level of the vitamin C. You can use ascorbic acid in the diet. May also help protect fish against nitrite toxicity. The vitamin apparently acts to reverse the process of conversion of hemoglobin to the methemoglobin. Salinity. Salinity is basically the amount of elements and ions in the water after organic matter and suspended particulate matter are removed. The blood of a fish has a salt composition that is similar to that of the ocean water, but certainly not identical. Fish blood has a salinity that is typically around 10 to 12 ppt. This is the amount that must be maintained. Freshwater fishes do not drink more water to maintain salt and produce very dilute urine. Marine water fishes have low salt than its environment and move water from body tissues to the outside. So fish drink a lot of water to avoid dehydration and produce concentrated urine. How you can measure the salinity? Electrical conductivity of a water. A sample also relates to salinity titration. The easiest method of determining salinity is by measuring the refractive index of the water. Alkalinity. Alkalinity is the capacity of water to resist changes in pH by buffer system of the chemical reactions that occurs in the water. Freshwater alkalinity levels is between 30 to 200 mg per liter. Though higher and lower levels have been used in many instances. The minimum recommended level is 20 mg per liter. How you can measure the alkalinity? You can use the titration method, or you can also use other chemicals like indicator chemicals like phenolphthalein and methyl orange. Non-methyl orange endpoint provides the total alkalinity value, while phenolphthalein endpoint indicates the bicarbonate alkalinity. The concentration of divalent cations in a water sample is called hardness. The dominant divalent cations are calcium and magnesium. Freshwater fish should be reared in water that has a hardness of 20 mg per liter or higher. But in marine water, there is no need to measure the hardness. Measurement of hardness is determined through a titration process, and like alkalinity is reported in milligram per liter or parts per million of the calcium carbonate.